Welcome everybody. On behalf of the Conservation Commission, which I chair here in Moncton, I'm going to have Conservation Commission members stand up and wave, please. We're missing one team. So I hope you will enjoy this presentation, and also if you can find one of these flyers. One of the big projects we're working on right now is getting some maps together for our community that support forest connectivity, and we're hoping this talk will help you understand why it's so important in our community. And we are also looking for members, so those folks who stood up, or me, we hope you'll also reach out and want to join us, because we do really fun things like this all the time, I promise. Our meetings are the best. So now I've introduced us, and Laura Farrell is going to introduce our presenter.
So welcome everyone. If you've seen the announcement, and I assume that you have because you're here, or one of these two editions of Wetland, Wildland, and Woodland, you have an inkling who Eric Sorensen is and why it's such a treat to have him here. He's the community ecologist at the Vermont Fish and Wildlife Department, and he's been busy describing and classifying Vermont's natural communities and getting them mapped out as finally as possible. So he's the co-author of both of these editions of Wetland, Wildland, and Woodland, which I would suggest anyone who hasn't seen it, check it out. It's got beautiful line drawings and pictures and really clear and short descriptions of the communities and what's in them, and some of the special things you might find and it also says where you can find them. So you can go check them all out. So he's worked in a number of different realms to help conserve some of the treasures in Vermont, and from field work to legal work to education and helping people figure out what's where on their land. And he's pretty sure Moncton is a special place. He's going to tell us why he thinks that. And I just wanted to make a special note that we're really lucky to have Eric here. He's about to retire. So this is one of his last talks, and enjoy.
Thanks, Laura. I've got 6 more weeks, so that's quite a bit of time still. But Steve Perrin was my boss, so he's here, and he can't critique me anymore because he's not my boss anymore. But I'm following.
Never understood it anyway.
I'm following him into retirement. It's great to be here. I really do think Moncton is a special place. There's just a lot going on here, and my goal tonight is really to give you a sense of Moncton from my perspective. I can't duplicate what Moncton residents know, and you know a lot more detail about the place than I do. I've worked here as much as I can, and I've been to many cool places here, but there are many more. Like just tonight at dinner, I learned that there's a kiln somewhere. Kiln? A marl bed. So I mean, there are all kinds of things, and it's for you guys to discover. So I want to go through. I want to talk about landscape features. I want to talk about natural communities. I want to put those in the perspective of the Vermont conservation design, which is kind of a vision, a tool for looking at how we conserve biological diversity for the state. I'm hoping to go for about 45 minutes and then have time to talk at the end. I do have 2 copies of the Wetland, Woodland, Wildland book that Laura mentioned, and I have an idea for a kind of a contest at the end. So if you remind me about that too. So it's almost a requirement that we start with our department mission, but it's actually relevant because it's a pretty cool, broad mission. That's not good. It's the conservation of fish and wildlife, plants and their habitats for the people of Vermont. I mean, that's pretty much everything. I mean, there isn't anything that's not really included in that. So I like that. It gives us a breadth to study and work on lots of things and focus where we think it's appropriate. I want to start off by going way, way back, like 500 million years ago, and put Moncton in perspective. And Moncton could be forming sort of out there in this shallow sea about 500 million years ago. And I know there's a geologist in the room, and there are other people with expertise in the room, and if I get something wrong, please just correct me, okay? Especially about geology, though. So this could be where Moncton is forming, and it could be somewhere where that little question mark is, in the shallow seas in the Iapetus Ocean 500 million years ago, when sediments were running off the landmass and forming the sandstone base that became the Cheshire Quartzite, or the lime-rich limestones that were part of the seabed. But that's a long time ago, and over time the continents have sort of gotten to where we picture them now. Like, there's Moncton, in where you know it with the little green star there, and now we're sort of in this place in Vermont, a really special place in the Northeast for lots of reasons: topography, bedrock, the diversity of biology we have here, the people that care about the place, which I think is really important. One way that I start thinking about a place is how it fits into these biophysical regions. The biophysical regions they're described in our book, but they're also, it's a way of sort of thinking about parts of the state that hold together for several different reasons. You can think of bedrock or climate, sort of a predominance of vegetation that you'd find in particular places. So like the Champlain Valley and its flats are really different than the Northern Green Mountains, which are really different than the Northeastern Highlands. And those differences give us one way at a very broad scale to sort of categorize the landscape. So the special thing here about Moncton is it straddles two biophysical regions. Has anybody seen this bedrock geology map from 2011, 2012? This doesn't do it justice, the colors here. And if you had the full map, it's about the size of where the door is there, almost up to the ceiling, maybe halfway up to the ceiling, in two panels. And it has some 500 or 600 categories of bedrock geology. And the colors don't even come through here well, but it's just a beautiful map. But it tells us a ton about what the state is, about what's here. And you can see where Moncton sits in the bedrock geology map there. And if you zoom in closer and look at just Moncton and use we call it an ecological classification of bedrock, but it's a grossly simplified version of those 500 to 600 categories into these 12 categories that are especially important from an ecological perspective in terms of how they form vegetation, how they weather, how they perform over time. And in Moncton, this is the hogback and the little hogback out here. And those are made up of this really hard and generally more acidic rock, the Cheshire Quartzite, which, if you're familiar with the Green Mountains, the Cheshire Quartzite goes all the way south, all the way down to Bennington, maybe beyond, as that steep, sharp edge of the escarpment that forms that sharp edge of the Green Mountains. And then the Moncton Quartzite named for here, or the town is named for Moncton Quartzite, I'm not sure which came first, which is in that dark blue category up there, which says locally calcareous quartzose. I love these descriptions. Metasandstones, slates, and schists. The Moncton Formation is an example. And it's important because of that calcium, and I'll explain a little bit more with the Dunham Dolostone, which is that's the rock formed from marine creatures, along with limestone, sort of in those shallow seas. And it's highly calcareous. The calcareous means that it has calcium available for release into the environment and for forming soils and for providing nutrients. Calcium is a really important plant component in plant metabolism. And the presence of calcium is associated with many different community types, but also regionally, studies have shown that the abundance of calcium, say by state, or the abundance of calcium-bearing rocks by state is a really good indicator of the number of rare species, especially rare plants. And Vermont has much more calcium-bearing rocks than anywhere in the Northeast, way more than New Hampshire, way more than New Hampshire. And I like New Hampshire, but it's all granite. And it really does make a difference. And if you look at a place like Moncton, having that combination is really important for what you see here in terms of vegetation and natural communities. So after the rock formed, getting close to present, just tens of thousands of years ago, the glaciers came through. And that could be Snake Mountain over there. It's a little big for Snake Mountain and the glaciers coming through. But over us here, there was anywhere from a mile to a mile and a half of ice. And that lasted until about 13,000 years ago. And it pushed down the crust, sometimes hundreds of feet. And it scoured the landscape. It brought in soils. It totally changed what the surface looked like. And from that period from the period that the glaciers left, from that time, a couple of dramatic things happened water-wise. One, shown in the solid blue in that, is Glacial Lake, Vermont, which lasted, it was here right after the glaciers left, and stayed up until, hard for me to see here, stayed up until about, I can't read that clearly, 8,000, 9,000 years ago, something like that. And that was a period when Moncton was an island. Parts of Moncton were an island surrounded by this huge glacial lake. What's that? Is that what's on the eastern side of Moncton there? That's not Shellhouse Mountain, is it? That's in Ferrisburg. So, but the Hogback, Hardscrabble Hills, and the little Hogback. So it was an island, and then about sometime after that, this is partly in response. The Glacial Lake, Vermont, drained to the south, out the south end of the lake, and partially in response to the rebound of the crust. The drainage went to the north, an ice block broke, and the ocean came in. And the ocean is the hatched area. The ocean coming through is why we have fossils of whales and things like that along Lake Champlain. And that lasted for, I think it was like 3,500 years that it was a salty sea. So I mean, that stuff, it's not really evident now until you start looking at features that are associated with these large lakes, like the clay plains, that are the results of fine sediments washing into the valleys and being deposited in either the sea or the lake, or the deltas that form at the mouth of some larger rivers, like especially the Winooski. this is a map of, an older map of surficial geology, sort of, it's like combined soils, the way I think of it, but where they originated. And the cool ones here, to me, the standouts are the pink, which is just, and this is just called bedrock exposure. And all of the hogback is not exposed bedrock, but it's very shallow soils. The other one that's cool is the glaciolacustrin deposits, the orange. Those are all the places where those fine sediments came down into the valleys and formed flats, whether it's clay or some other finer deposit that's settled out in that sea or that ocean, or the Lake Vermont. And then, what other ones are cool here? Well, they're all cool, but glacial deposits, that's things like just the till, the material that's just kind of placed on top of the rock or on top of the land by the moving glaciers. This pluvial one, I never use the term pluvial, but you could probably use it in a cocktail party. And it relates to wetlands. And you can see Bristol Pond and the big cedar swamp up there. And what's the big swamp? Florona swamp up there to the northeast. But it gives you, again, a sense of the diversity of surficial materials here. Have any of you used LiDAR? It's like totally changed how I look at places. And like this is the whole town, 36 square miles. But if you zoom in, you can see woods roads in forest or old rock walls. It's incredible scale topography, and it really helps us sort of picture a landscape. And on top of all that, there are us. There's people and what we've done. Whether it's clearing for agriculture, or something I look at probably more now is how we've affected the ability of species to move across the landscape because of roads and houses and permanent changes to the landscape that change connectivity. So that's all I wanted to do on that part. I want to go sort of on a whirlwind tour through Vermont conservation design to give you sort of the background of how, at least how I think about what's needed. So, threats to biological diversity. The only one I'll mention, you can see those, the only one I'll mention specifically is climate change, that there's that direct, actually I've heard it more and more referred to as a climate crisis now. Climate change sounds a little bit like, yeah, the climate's changing, but there's a crisis and we need to do more about it. And actually some of what you decide to do for Moncton is related to how we deal with that. There are the direct effects that we are beginning to understand more and more. Intensity of storms, timing of weather events, change in sea levels, change in the water tables in the desert Southwest. So those kind of changes we know. The compounding effects are things like population growth as people view how nice Vermont is and decide this is a better place to live. And I like people, but New York is only 8 hours away and there are how many millions of people there, and we need to be ready to deal with that kind of change. And things like non-native species. Those are moving north as the climate warms. So climate change has happened before. In the past, it's been pretty slow. Like here's just an indication of from 12,000 years to 500 years ago. And the point of this is to show how species migrate independently. Beech and hemlock were separate 12,000 years ago, and now we think of them as overlapping in the forests. And the same with pine and oak. They were separate down there in the southeast, and they still are to some extent, but they have a larger overlap. Species move independently, and so Liz and Bob and I like to joke that our book is no good when climate change, because we describe natural communities that will be different assemblages as time changes. But the things that have changed since this period of climate change till now is first how fast it's occurring, and second, what we've done to the landscape, that the landscape is no longer connected. Species can't move around like they used to, and we need to account for that. The other thing we've learned is how important things like bedrock and soils and topography are to species movements. Those things you can think of as enduring features, or by this one analogy, they're called nature's stage. The stage on which life, the play of life continues while the species move around, the actors come and go. So protecting that physical environment, that physical landscape has become more important. This is the problem. We have some unknown number of species. We don't know most of the species we have. We know the groups that we focus on, vascular plants, invertebrate animals, and things like mosses and lichens. But we don't know most of our species. And there's no way that we can come up with a plan to protect each species individually. It's way too much. So the approach that's been used or proposed for decades now is this coarse filter, fine filter approach. That if we can identify a set of features, like this alluvial shrub swamp or this black spruce swamp, and protect good examples of those communities, we'll get the species that are associated with them, or conserve the habitat for the species associated with them, like wood turtle or spruce grouse or this moss splachnum that only grows on herbivore dung, moose dung in particular, in northern swamps, northern conifer swamps. So, and all those other things that we don't know. The problem is that those filters of natural communities aren't coarse enough. They're not big enough to deal with the issues like connectivity or forest fragmentation. We need other features beside those, and that's what the Vermont Conservation Design is about. It's trying to apply a set of coarse filters to work on how do we conserve most of those species. And it uses a set of features that the goal is that there's something that you can recognize, that you can go outside and see, yes, I'm in this forest block that begins at the edge of my yard and goes to the other side of the hogback, whatever it is. Or the riparian area that is along Lewis Creek or Pond Brook. But it's not like identify these things and then that's it. It's how do we steward and manage them now and for decades or centuries or millennia if we want to keep the functions that they provide. This project had lots of folks involved, and it's a map, it's a vision. This is the sort of jumping to the end of what the map looks like, and I want to explain what more of this means. But it's really the goal is to provide this intact, connected, and diverse landscape that allows species to move in response to climate change or and provide the habitat that most species need. And it's broken, the conservation design is broken up into really the two scales, the landscape scales and the natural community scales. And the species part of it is incredibly important, but it's something it's not addressed specifically by the conservation design. I'll try to explain that more. So I'm going to run through all these characteristics kind of quickly. This is what the set of landscape scale features look like. And you'll see in these maps and all the maps I'll show in the future that there's one large map that shows the feature and then the smaller map that shows that full conservation design with all the features stacked together. Interior forest blocks are the places where those species that are most sensitive to human activities thrive. And we need those spaces. And they do a lot of things besides just provide habitat. They're more and more we talk about environmental services or ecological services. And even services seems a little self-serving because it's not just about for us, it's about for nature surviving. But this set of blocks are some of the best forest blocks in the state. You'll see in places like the Champlain Valley that there just aren't very many big blocks left. It's mostly agricultural land, but you can see there's the hogback sticking out. Am I in the right place?
Yeah.
Yeah. So this next, I'm not going to go through this information for all the others, but I think it's important, especially for Moncton, when you're thinking about what to do about this information and how to use it. For each of these features, we have a set of guidelines on what it means to maintain the ecological function that an interior forest block or any of the other features provides. This cannot mean you can do nothing in any of these forest blocks. That would be unworkable. What it does mean is we have to figure out what you can do in those places and still maintain the function. So for interior forest blocks, what we want to avoid is fragmentation. Like this house, which is in the middle of that block, shown in the photographs in the arrow, which is about a mile-long road right to the middle of the ridge. You do that 3 or 4 times, and a lot of the interior forest function of that block is diminished. If you instead build along the edge, maybe not here because that connectivity is so important, but if you pick other places to build, you can build and not lose those functions. So the other part is about forests. So much of Vermont is forested. This is not about having all these areas be unharvested. That's great in some places, and we absolutely need that. But if you harvest forests in an appropriate way, you can maintain a lot of the function too. And it helps landowners keep their property from being fragmented more by development sometimes too. Anyway, I just wanted to point out that these are sort of non-prescriptive ways to think about how to maintain the functions. And when Moncton's thinking about what to do with all this information of forest blocks and riparian areas, and Moncton has a lot of them, I hope you're not overwhelmed by having so many. I think of it as an honor that you have so many. Connectivity blocks, it's another set of forest blocks, but the difference is that these form these continuous pathways across the state, and you can think of them as stepping stones of smaller blocks and the larger blocks that together form a network that allows species to move. And you can see places where there are constrictions, like up there, right up there. And those kind of places, those are some of the most sensitive. If we lose even a few of the connections there, we're going to lose that landscape connection that provides more regional connections, say from the Adirondacks all the way up to Cape Breton. Surface waters and riparian areas, I'm going to go through some of these others a little faster. This is all the rivers and streams and lakes and ponds, and you can't pick some and say some are more important than others. So they're all here. Every one should be included in some form as being protected with enough buffer to maintain water quality and habitat values. Riparian connectivity is a section of the rivers and streams that's shown in brown on this map, where the blue is that full width of a valley bottom that is sort of where it's both where water accumulates, but where there are alluvial soils, and it's really the full path in which the river or stream could move. The riparian corridors are the portions of those that are naturally vegetated. Where we have those riparian corridors allows for animals to move and provides important water quality functions. And especially in places like the Champlain Valley here, those connections become the best connections for movement of species between forest blocks when there aren't any forest blocks. Physical landscape, this was a complicated part of the project. A coworker, Bob Zano, did most of the work on this. And I'm not going to say any more than the red areas were added to the overall design to fill out representation of all the different physical landscapes that we have. It's a very cool part, and I think it's critical. And yeah, I'll leave it there. There's a lot to it. It's pretty neat. Wildlife road crossings, you guys have a lot of familiarity with this, but it's a landscape feature in that these sections of road become conservation targets. You don't usually think of roads as being a place to conserve, but this section of Route 100 between Waterbury and Stowe is the best connection left between the Green Mountains and the Worcester Range through this little block, this North Hill block. And similarly here in town, you know, it's not just about big animals moving, it's about small animals moving too. And you guys have a great history of establishing that connection here in town. So at the natural community scale, those are all the landscape scale features. At the natural community scale, my favorite is natural communities. There are about 6 features at this scale. And for those of you not familiar with a natural community, it's just a repeating assemblage of plants and animals that you find in a similar environmental setting. And right now we have 97 types identified for the state, and we have targets for how much of each we need. Like the rarest types, we need all of them represented. Rarest ones were, there are only 5 examples of them in the state. And for the more common types, we have to have a subset of those that are represented across the state where they occur at natural scales. These are still one of the most important coarse filters, a step above individual species, but where species are known to recur. What I wanted to do is just quickly sort of go through some examples of natural communities. First, sort of statewide, montane spruce fir forest and boreal outcrops, red oak northern hardwood forest, pitch pine and red pine forests and woodlands on the left, pine oak heath sandplain forest, intentionally lit on fire in Chittenden County. They're a fire adapted community. Peach and bog, best or largest example and my favorite dwarf shrub bog in Vermont. And lower right, the red maple black gum swamp. Really small little pocket swamps down in southeastern Vermont with trees up to the black gums, and this could be 300, 400, 500, 600 years old, the oldest trees we know of in Vermont. That alluvial shrub swamp again along a small brook, and then along the West River, the river cobble shore next to the water, and further back a river shore grassland. So those are statewide. I just wanted to focus a little bit on Moncton's natural communities, and the legend here are just a set of the natural communities that we, the Natural Heritage Inventory and Vermont Fish and Wildlife have mapped in Moncton. And I'll start right off by saying this is just a taste of what's here. And it's what we know about right now in our inventory work and data. And I think Chris is going to be working on more of this. And there's tons to look at. But a really good assortment of things here. A really interesting assortment. And just a couple photos of what those look like. The north end of Bristol Pond and the wetlands, these maps, you can see the symbol about where the photo is taken at the lower right there, the little red asterisk. This wetland complex is awesome, you know, from poor fens to intermediate fens, black spruce woodland bogs, a lot of it just unmapped in terms of type. Incredible marsh habitat, pretty altered by what people have done to it over the years, from flooding and stuff, but incredible place. The hogback is it's like the feature when I think of Moncton. I think of the hogback sticking out and how important it is. Charles Faree, Carolyn's partner, did the biophysical regions map that we use now. And I argued with him when he drew the new map that showed the hogback as being an extension of the southern Green Mountains, because the southern Green Mountains are way down there, and the northern Green Mountains are right next to us. But the hogback has all these characteristics, bedrock and presence of wetlands on top, and all these other features that Charles identified that link it much more closely to a continuation of the southern Green Mountains. So Moncton has this extension of the southern Green Mountains that extends way up into town, which is kind of cool. But there's a list of the communities that are known just from this one this one area near that asterisk on the hogback. Anybody know what this oak is? Nope. Yes, chestnut oak. It's got that's in this area too, and dry oak forests. It has lots of veins, up to 12 veins. The tips of the leaves don't have little bristles on the end. It's in the white oak group, and chestnut oak has that really, really furrowed bark that you find on dry ridges. Like a tree like that will have bark. It's like a cork oak almost. That's just the north end of the hogback looking south, and the eastern slope of the hogback looking back towards Pond Brook. This was a total surprise to me. Down there in the southern part of Moncton, there's a black spruce swamp and a red spruce cinnamon fern swamp. I didn't even think there'd be any black spruce in town, but there's a swamp. This is something that's typical from way up north, and it's in a cold depression in the southern part of the town there. I think this photo is probably actually taken in Bristol, but this section of, is this referred to as Hardscrabble Hills, is that right? Is part of VFF's, Vermont Family Forests land, is that right, Kelly?
The watershed.
The watershed center land, yeah, sort of beginning there, but yes. That whole section is totally impressive. All kinds of cool communities there, from rich northern hardwood forest to other oak forests, lots of embedded wetlands. And then this one is a cool hemlock, balsam fir, black ash seepage swamp that's near Pond Brook, and has this very rare coltsfoot and a more common Canada honeysuckle. So just back to this about communities, there's a ton here that's unexplored. Like I look at our mapping and how we have nothing mapped in that entire region. And I mean, you could go almost anywhere here and find really important natural communities, and the whole north end of the hogback, for that matter, is unmapped. I didn't mention the Pond Brook cedars. That's an incredible cedar swamp in there, too. So, any doubt that there are great natural communities in Moncton? I hope not. A couple of the other targets that are important. This is one that actually I thought would be sort of a controversial part of Vermont conservation design. We have a lot of middle-aged forests. We have a lot of forests that are kind of in the 60 to 100-year range. And I mean, that's fine, but they don't do a lot of things. They lack structure that's really important and found in old forests. They lack some of the complexity of species that you find in older forests, where you develop deeper soils and fungal networks and those kind of things that we're learning more and more about. And they lack some of the structure of young forests that are especially important for a suite of birds, neotropical migrants. So we have targets for old and young forests that are actually pretty I think, kind of mild. The 3 to 5% young forest is, that's based on what was here, what we expect was here prior to European settlement. The target for 10% old forest statewide is modest, but would get us a lot of the function that those old forests provide. Aquatic habitats, these are sections of rivers that have some special features, like high elevation streams that are important for brook trout and are likely to be impacted by climate change. The lower sections of larger rivers that flow into Lake Champlain, below what they call the fall line, where there's a break, and the species that are in the lake can only migrate up so far. There's some really cool species associated with those lower sections. And a set of lakes and ponds that are representative as well. Like rivers and streams, all wetlands are important, so I think you're pretty familiar with that. I did just a little quick analysis of Moncton's wetlands, and you have way more than your share, which is kind of cool. If the town is about 23,000 acres, and there are about 2,700 acres of wetlands here, which is almost 12%. The statewide average is more like 3.5%, I think. But very cool features, incredibly important for function, for ecological function. Grasslands and shrublands, this is always sort of another one that's kind of controversial. We don't really have natural grasslands in Vermont. I mean, they just aren't here. It's a forested landscape, and other than things like sedge meadows or beaver meadows, we don't really have many natural grasslands. But with our agricultural activity, we created a lot. And with those grasslands that we've created, we have this set of species that depend on it. So it's not, it doesn't seem like much to ask, and it hasn't been controversial to say that we need to protect that habitat. And so this comes up with a plan on how we come up with a set of areas in the dark yellow where we need something like 7,500 acres that is managed for grassland birds. Moncton's solidly in that dark yellow area in the lower left. And then a larger area in the tan color where we work with farmers to manage hayfields, or some of them, in a way that's friendly to grassland birds. We think of underground habitats as caves and important for bats, but there are all kinds of other species there that we know little about. We're lucky to have Alyssa Bennett now working on bats. They've gone through a huge decline because of white nose syndrome. I think up to 95% declines in some of the populations, like little brown bats. We don't have a map. We do have maps of those, but we don't put those maps out there because the locations of those caves are so sensitive. That's all about those things. I just want to say two things about species. There are a lot of species with climate change that are either going to move into the state or are going to exit the state. And we could fight those. We could say, no, we like it the way it is, and we want it to stay this way, or we could think about how to make Vermont a place where the species can move. And I mean, I think we really have no logical choice other than the second. Here's an example of one that there's nothing to do about, in my view. This northern pale painted cup is a very rare plant in Vermont. It only grows on these cliffs, these steepy cliffs in Smuggler's Notch. It's a species of the far north and is there because that's this amazing, cool, calcareous place here. With global warming, it's likely to leave. And I think that's okay. Like, we'll miss it, but there'll be more of it to the north. I think you could probably say something similar about moose over time. They are declining. They are very abundant and very healthy to our north. And what we do with them here in Vermont is something we should be careful with, about how we spend our limited resources. So some species will stay around and some won't. There are other species that I think we need to, you guys recognize the guy in the lower left there? Steve's work focused a lot on spiny softshell turtles and their conservation. But here's a species that, if we don't take care of them, they are in trouble. They nest on these shale beaches along Lake Champlain, and there are predators from raccoons especially, and if we don't protect their nests and don't deal with them individually, they're in trouble. And you can come up with a whole set of species that need our individual help like that for one reason or another. But the goal of Vermont conservation design is we've captured most of the species with those set of coarse filters, so there are many fewer like this that there are many that we can say we don't need to do that individual attention to, and it gives us the ability to focus more on those that need it. So that's that conservation design, that's the idea, that's the set of maps. It's about 60-some% of the state that's shown in some color there. That's a lot. And, but it's what's there now, and it's not, again, saying that we can't do anything in those places. It's that we need to conserve the functions that those places provide. And I think that's actually very doable. It's something that we can decide to do if we want. It's a collective decision. I approached this as a geeky scientist. That's what we were told to do, to come up with a plan, and all the folks that worked on it together, that was our charge. But as we get to the end of coming up with this Vermont Conservation Design and Division, it's so much clearly about more than protecting biological diversity. It's about all these other things. It's about, I think, about why we live here, and about the place. Again, the Vermont Conservation Design, it's a vision. It's something that we can choose to do if we want. Vermont is 80% privately owned. 80% of the land is private. And this will only work if we can make it work for landowners. They're sort of the key to success, and that comes down to how do we as a society support their ability to keep their lands ecologically functional. I like to think of this as not a smorgasbord, not a buffet of features, all those different features I've gone through. We need all of those. And some organizations may focus on some and some on others, but we need all those features. I like to think that something like the conservation design is a way to unify conservation in a direction. And actually the Vermont Conservation Design is very similar to now a nationwide conservation plan that the Nature Conservancy's developed called Resilient and Connected Landscape. And I think the Vermont Conservation Design is better for Vermont because it's more detailed and more focused, but they use the almost identical approaches to looking at landscapes. And again, there are these social and economic values of keeping that landscape. Just a couple slides. I want to just go back to Moncton again and just make a couple points. This is a map, again, of the roads and houses in reds, and riparian areas in the larger areas of riparian surface waters and riparian area in the light blue, the rivers themselves in dark blue, and then those riparian corridors in brown. And the connections that these riparian areas make in Moncton, both connecting up to the Green Mountains through Lewis Creek and through Little Otter Creek, and the connections made by Pond Brook and all the streams that flow through town are kind of a backbone of that small scale connections that are really important to connect to maintain. If you look at those Vermont Conservation Design features for Moncton, the colors are kind of funky here. Connectivity blocks, interior forest blocks. The red are those physical landscape diversity blocks, and the brown is those surface waters and riparian areas. The thing that stands out to me about Moncton is, again, the hogback, which provides this connection down to the greens. but also how far into the Champlain Valley those forest blocks extend in Moncton. There's no other place like this in the southern Champlain Valley. The only other place that this occurs is up near the Winooski and north, where there's some blocks that go up pretty far. So this ability, or this characteristic that's still here, and I think it's largely because of these both acidic and limey cobbles that are in this area that remain, that haven't been developed, provide this connection further out into the valley than any other place. If you zoom in just a little bit more, the only thing I've added here are the green lines. Those are sections of roads that have been identified as important wildlife crossings. And I mean, some of these, you know these better than me, but there are sections like this that are long sections with one house in it. And this is the kind of place where if you're going to build houses next to this block, build them here or here, not along this section, or maintain a section of that road so that you can maintain connectivity across that road. But this sort of shows that pattern. You can sort of see the places where there are constrictions. There's a place where there's one of the few, what road is this? I don't know that road myself.
Mountain Road.
Mountain Road. I mean, there are just a few places on there where there are good connections across. And identifying those and thinking about what to do, how to address landowners' concerns in those areas, I think are really important. That's it. I want to sort of summarize quickly. You've got this incredible diversity of bedrock soils and topography. You're at the intersection of the Champlain Valley, the southern Green Mountains, and right there to the east is the looming Green Mountains. You have some of the most intact, large, limey hills in the Champlain Valley. Those hills that are, I didn't mention that before, but there's a lot of information that show those topographically diverse hills. And Hardscrabble Hill is topographically diverse. I mean, it's got angles in every which way. Those places are some of the best places for local migration of species, that you don't need to migrate or shift your range hundreds of miles if you've got a topographically diverse block and you can go around to the north side or find a cool alcove or a south-facing slope. You have large forest blocks of all of the three types. You have these rocky, durable, and mostly intact hogback, Little Hogback, Mount Fuller, and Hardscrabble Hills that together provide that important connection out into the Champlain Valley. You've got amazing riparian corridors. And in town, it's mostly those small streams, I think, and Pond Brook that provide those connections to Lewis Creek and Little Otter, isn't it? And many state significant natural communities with many more still to be looked for. That's what I've got. Is there any questions or ideas? Hi, yes.
Hello, you've made a great case for Moncton, and I don't challenge that at all. Where else, if you could choose like 3 or 4 other places to give this talk, would you want people to really understand the importance of their town?
Well, that's sort of a leading question, because I would try to do it in any town. Like I wouldn't, you can't make the claims that you can here, especially in the Champlain Valley. I mean, I think that's what makes Moncton special. But the cool thing about this kind of approach of looking at a place is that whatever you have is the coolest thing there. And I really believe that. I mean, there are towns like, I'm trying to pick on one that would be difficult, Addison maybe. I mean, well, they've got Snake Mountain. But, you know what I mean? Like,
yeah.
Almost any place you go to, you can find those things. And in some places, you don't have the limey cobbles or the hogback, or you don't have Pond Brook, but you've got a set of streams with riparian buffers, and those things are the most important there. Or you've got clay soil that you can restore. So, yeah, that's
That's a great answer. I mean, every town should celebrate the
yes.
things it
Yeah,
has.
I think so.
Yeah.
But I mean, it's easy to celebrate here.
Do you know if the white nose syndrome has declined? I saw bats last night for the first time in years around our farm.
I was in Cornwall yesterday at a property, and they've got a bat house on the side of the house, and it's just full of guano underneath, and they think it's big brown bats. I know that there's some resistance. Steve may be able to answer this better than me. I know that there's some resistance now, there's some rebound. We're sure not out of the woods at all. And Steve, can you add anything more?
With different species, the northern long-eared hasn't really recovered that much. We have some hope for the little browns haven't recovered a bit. Still just a shadow of what they were. It's confused because bats are social animals, and we think that there's some consolidation of roosts. So as their population has thinned out, some of the roosts have been abandoned and they've piled up in other places. So, Alyssa's trying to tease that all out. It's not a clear picture, but we kind of think what we're facing here in North America is what Europe went through before recorded history, because Europe has a very popular bat population compared to here. And the fungus that we got hit with actually got transported from Europe, we think.
So we may not get full recovery of the years of
Well, it just, they don't have a lot of pups.
Right.
So it'll take decades, if not centuries, and they never recover, because the fungus is living freely in the mines and caves and aren't dependent on the bats to keep it going.
Yeah.
Could you go into a little bit more detail perhaps on the perspective on invasive species? I'm intrigued by that because I understand what you're saying about some species will move out of the area. Similarly, we have some moving into the area, and I struggle with where the line in the sand is on which ones we should try to keep out and which ones we
Right.
should just say they're moving through, and what comes to mind this time of year is poison parsnip.
Right.
What is the perspective
Thanks
on
for,
that?
thanks
How
for
do
bringing
you know?
that up, and I probably wasn't clear. The comment I was making was about native species.
Oh,
And
yeah,
the-
okay.
The native species that are here and may shift north over time, or southern species, native species that may shift here and become native to Vermont in the future.
Yeah.
Like I sort of view that as kind of an accelerated natural process now. And I mean, there's so much discussion and perspective on invasive species and what to do and what not to do. My view is we should always be vigilant to slow the additional spread from the south or in the state of species that we can. Absolutely. And I didn't mean my comments at all to mean we should be relaxed about invasives. There are some that I think
It made me think of
Yeah,
that
yeah.
and wonder what your perspective is.
there are some that I think we have little chance of controlling, and others that we have more chance. You know, things like this new one to me, wall lettuce. Each plant produces 1,500 viable seeds a couple times a year, and it blows around. It likes calcareous soils, and I don't know if we can do anything about it. There are others. I'm trying to think what others. There are things like a lot of folks manage, especially the woody shrubs on their property, honeysuckle and buckthorn, and are very successful in doing it on a property scale. And I think that's very helpful. How we manage our forests is also a big deal in whether we increase invasives or not.
Thanks.
Can I give away 2 books?
Yes.
Maybe this is kind of hokey, but all I could come up with is who has lived in Moncton the longest, and who has lived here the shortest time?
53 years.
53? Can anybody beat 53?
Is that the short time?
Right. Seriously, is that easy? Wow.
The next question, does the Moncton Library have this?
I was gonna ask that too.
Check.
We'll find out.
And who's lived in Moncton the shortest time? Like, you've got to actually live here, not like visiting your uncle or something like that. A year?
8 years.
A year? Anybody less than a year? How long?
A couple months ago.
4 years?
No, like 8 years.
Oh, 8 years.
Yeah,
4
just
years?
But Anne's 4.
Ian's for?
Anne is.
Oh, Jim, we'll go.
4 years?
Yeah, but I have the book.
Okay. Fine. Who's next?
We're 6.
6?
We also have.
We have.
Does the library have a copy?
2 or 3 years? How long have you lived here, Dad?
4 years.
Oh.
40.
The libraries know.
The library should, how about a copy for the library? Copy of the library?
Okay.
Great. Any other questions? Anything else? Yeah.
I was intrigued because I live on Moncton Pond,
Uh-huh.
or Cedar Lake, whichever. I was intrigued a little bit and surprised at the wetlands, the extent of wetlands, and what is it, sort of an upland environment. And is that it seems to me that a lot of that is due to 50 years of beavers. Transforming in a really significant way this little valley. You go back Old Hollow Road and a little valley down in there, and I'm told that 50 years ago it was all wooded. Now it's all filled in with a bog essentially, and apparently it's due to the beavers. And is this considered just natural evolution of these areas, or is it a nuisance, or is it?
Well, it's probably some of both. In general, I don't think of beavers as creating wetlands long term. I think of them as, because they're transient, because they come and go with food supply. The places that they use tend to go in cycles, and they tend to go in a cycle of, they can definitely flood out swamps, they can definitely flood out upland forests, but the extent of upland forests that they're flooding out, I think, is fairly small. And I mean, you can recognize the places where they're repeating because of the. Actually, it's a natural community question. We can't really classify a place where beaver are to a natural community because it doesn't stay put, because it changes so rapidly. It goes from, a shrub swamp or sometimes a forested swamp to open water to sometimes mud flats to meadow to shrubs again, and that cycle can go on and on. So, I don't know the particular place you're talking about, but in general, I don't think with the number of beaver we have now that they are creating a lot of wetland. I think they manipulate a lot, and they can definitely be a pain for a landowner who's got forests that they want to maintain. Does that answer your question at all?
Yes, it does.
Okay. Yeah.
I actually had a question about Moncton Pond too. I noticed that the plant communities there are like much more acidic. They're more typical of an acidic, and I guess the environment is acidic there as well. But I just wondered if that was like driven by the bedrock or driven by poor drainage, or if you had any insight as to how that.
I was just going to look at the bedrock geology map. I don't know Moncton Pond. So if anybody.
It's also called Cedar Lake.
Yeah, like I know the spot, but I don't know it from what's there. And I don't know where it is on here.
say it's there,
So no, I don't know. Does anybody else know? Carolyn, do you know anything about the environs?
I would say it's there. I haven't done
I wonder if I can see an outline of the pond there.
If I had a decent map, you could.
Is that it?
Oh,
So
yeah,
that little bit of a
yeah.
dark circle there?
Yeah.
So, I mean, that would put it up against the Cheshire Court site, which would be a more acidic site,
Okay.
and over the Moncton Court site, which is kind of variable in its degree of calcium-bearing rock. Yeah, it comes down to the edge of it, doesn't it? Yeah. So, I don't know.
When you say acidic plants, what are you seeing?
Like leather leaves and, trying to think of what else
So
was
bog.
there, but, yeah, it's definitely like acidic bog type vegetation.
I mean, the other thing that could be is there's this pioneer plant community that, including leatherleaf, that it's really good at pioneering into edges of ponds, open water, and like you can find leatherleaf in rich fens too. It's not restricted to acidic. It's that it's a good competitor in acidic conditions. But if it's a pond shore community with leatherleaf, that could still be really alkaline even. Like it's not. It'd be good to. There must be some pH values for the pond. It'd be interesting to know there. I don't.
Okay, somebody told me too that they had mined peat out of the pond, does anybody know about that, that it was
Don't know.
harvested peat years ago?
Yeah, Kelly.
Question. I was just wondering how the natural communities in Moncton were identified, like were they for mostly conservation projects or, you know, like what, and what, in the future, like what would additional areas be
Right.
identified?
The Natural Heritage Inventory that I work for, part of the Vermont Fish and Wildlife Department, and really my primary job for the last 25 years has been to do natural community inventories, both by myself or with coworkers or with contractors. And before I was there, that had been going on since late 80s, something like that. And it's kind of a mishmash of approaches. Like cedar swamps, we did as a batch statewide, looked at where all the cedar swamps were and went to look at some of the best examples, like Pond Brook cedars. Others have been kind of hit or miss. These days, we identify a lot of new state significant natural communities because of use value appraisal and landowners wanting to enroll their properties differently. There isn't any one approach that was used in Moncton. It's sort of across the board. Or like the hogback inventory was a great conversation with, that's land managed or owned by Bill Sayre and Company, I think, isn't it? Great conversation with them, and they said, absolutely go look at natural communities and tell us what's there. So we went and spent days looking at that. So I mean, it's really kind of a mix. But I think I pointed to some places that are priorities. I mean, it's the hogback, it's those, all the hills, all the interior of the hills are full of cool things. And I mean, there are nice approaches now to do sort of landscape assessment, you know, looking at, I mean, just these kind of features, like where are the big blocks, where's the calcium bedrock, where do you find really steep slopes, where are the pocket wetlands, and where do you find like seepage wetlands that you might find on Cabot soil. So I mean, you can go through a whole range of things, and that would be the systematic thing to do for Moncton, and I think Chris is on it. Is that what you're doing, Chris?
Yeah, we're mapping some of the blank spots.
That's, yeah, so it's a job. I mean, there's a lot to do here, and I yeah.
And Chris, I hate
hate to put you on the spot, but would you mind introducing yourself to everyone here real quick?
Yeah, I'm Chris Aiello. I'm a grad student at UVM, and yeah, I'm just doing some mapping for ANAC and the Conservation Commission. So.
The other part of it, Callie, is where we get landowner permission. And you know, as a state agency, we don't go inventory on properties where we don't get permission. In general, for natural communities, people are really welcoming because it's.
Get they learn about.
Yeah, I mean, it's sort of what cool things do you have on your property, and you know, like it can help you if you know, change how you manage your property, that kind of thing too. Yeah.
To that extent, has the Vermont Current Use Program been an effective vehicle for trying to introduce those ideas into the minds of willing landowners?
I think so. Actually, there's a UVM grad student, or past field naturalist, Carolyn Loeb, that worked with a set of landowners introducing Vermont conservation design, and specifically relative to the use value appraisal program, about here's what you have on your property, this is what additional options you have for how you manage it, sort of in addition to the regular silvicultural guides. And you know, I was out with a consulting forester all day yesterday, and that's, I think, the interest in alternative management of forest properties is intensifying, especially for things like old forests. People are very interested in what can we do to manage a portion or all of our property as old forest. But use value appraisal, there are, I think, 2 million of our 6 million acres are enrolled. So it's an incredibly important tool in Vermont. The only criticism I would make for it is that there's nothing permanent about it. And with pressures from property values increasing and pressures for people moving here, the disincentives for coming out of current use are pretty easily outweighed by the value of property. But it's an incredible program, I think. Anything else? Yeah.
I have a question that's come up to me a couple of times now, but when you look at like the identifying priority road crossings,
Yeah.
and the filter to me seems a little off in spots.
Yes.
Like they've identified, these are the ones that are already a problem. And there are ones, I mean, there's 2 roads near me that aren't even roads, they're impassable. And I can't get up them on my tractor.
Oh, and they show up as green.
And they show as roads,
Yep.
but they're not identified as an important crossing, because if you look at them now, hey, it's a great wildlife crossing now, because you can't get a car through there. But if it ever were connected, it would be another mountain road scenario.
So is that a class 4 road?
Yeah, well, it's on the map shown as a connected road, but there's, what, 2,000 feet that you can't, you know, there's trees this big growing up there.
And you're saying it's shown as green on the map?
No, it's not shown as green.
Well,
I thought green was the priority, right?
It is, and actually that exact thing was a big discussion when we made these maps. I lost the argument, just so you know. The argument was, should we show class 4 roads as important for connectivity?
Yeah.
And my argument is yes, even if it's ones like that with trees growing through them, that there's not an issue right now. But if there are still roads, they can be open, and the potential is there for them to be.
It wasn't too long ago that it was in the town plan that we need to open up additional north-south roads through town, and that was identified by name.
Right.
And it would just sever, because most of it's Nichols and Bennett Road, most of them are class 3.
Yep.
And then there's a portion that drops to, it's like a driveway.
Right.
But they both dead end.
Yeah.
Many years ago, they connected, and if they did connect, it would turn into Mountain Road. It'd be class 3 all the way through. It'd be high traffic all the time, because it's the best shortcut from Midbury for Jens up to. It's not a shortcut now unless you're looking for a footpath, certainly.
I think that's a really good point. I think those roads are, the potential for they don't provide a big connectivity barrier now.
Yeah.
Some class 4 roads have quite a few houses on them. Some are, canopied. So, they vary a lot, and it's that variance that makes them hard to classify. I would rather err on the side of showing those as important. Well, thanks a lot. I appreciate you all coming. It's nice to talk to you, and good luck in Moncton. Good luck with the inventories. Thanks a lot.
Thank you.